I hadn't intended to make a video today, but I saw that the Gemini API just came out and the pricing as well. So we'll just have a really quick look today and we'll follow up with a few more deeper dive videos into the more advanced functionality. At a first glance, it looks really easy to use. If you go to the DeepMind Google site, scroll down to the bottom, you will see Build with Gemini. And click into here, it will take you to ai.google.dev, which looks something like this. You should go and click into here and get your API key in Google AI Studio. Once you click into here, it looks something like this. So you can just go and create a new API key in a new project. You can just copy it and be ready to paste it into your Google Colab environment. Once you've done that, go into here and click on Read API Docs. You'll come to a page that looks something like this. We're going to go straight into the quick starts, Python. We're going to click into this Run in Google Colab and just walk through that notebook together. But before we do that, if you scroll down here, you'll see that they have a few other bits of functionality. This one's called semantic retrieval. At a first glance, it seems more powerful than the OpenAI file retrieval functionality because it can retrieve 10,000 documents. So I'm quite keen to go into that and also their function calling. And note, both of these are still in beta. We'll do that in a follow-up video. Remember to subscribe if you want to see those. Today, we're just going to go through the quick start and walk through the basic question and answer and also the chat functionality. The first thing that you need to do is to install the Python SDK for Google Generative AI. Then you need to import the necessary packages as usual. You need to set up your API key. If you've gotten it already and it's on your clipboard, what you should do is go to the secrets manager over here. You see a little key symbol here? Click into here. Yours will be likely empty. Add a new secret. Type Google API key here. Paste yours in here and select on to give this notebook access to it. So I've done that already. So once you've done that, play this. It should work. And to see if your API is working, you should be able to just play this to retrieve from Gen AI the list of models that we have access to here. It's telling us that we have access to Gemini Pro and Gemini Pro Vision. As of today, Gemini Ultra is not out yet. Okay, so in the first step, we're just going to generate text from input. In other words, question and answer. Just play this. So we've selected the Gemini Pro model here. And it's so easy to use, this SDK. You just take the model and you call the method generate content, and then you just put what you want to say here. So let's say, how many breeds of dogs are there? To get the response, you just call response.text, and to markdown just formats the output in a nice way for us to see. So exact number of dog breeds in the world is difficult to determine due to variations around 360 to 400. Cool, so that's pretty straightforward. There are times because of the safety guardrails, the API will refuse to return a result. And if you just do response.prompt feedback, you'll be able to see why it might have refused to provide a response. In this case, our question was pretty non-controversial. So the probability of it being harmful across these categories are all negligible. But if what you put in belongs to one of these categories, then you might see the probability being a number here, and that would give you the reason as to why you didn't get a response. The other thing that Gemini does, which I believe is different from OpenAI's GPT, is that it can return a list of possible responses, and they're called candidates. So let's just see if we got more than one here. Oh, so in this case, we only got one, but there is a configuration setting where you can set the number of candidates that you want to be brought back. This part is explaining how the API can also support streaming. So how many breeds of cat? We call the generate content method on the model in exactly the same way, and we save the response to this response object. The difference here is that we've added stream equals true. And if we just loop through response and print out each of the chunks, you'll see the answer coming through in 3 chunks. When you're streaming, some of the supplementary information will not come through at exactly the same time. So for example, this prompt feedback will come back, but this response.text will not come back until the whole process is completed. In this section, we can play around with Gemini Pro Vision, where we can pass in images and also a multimodal input, which includes text and image. So to start, we're just going to pull in an image into our local file space here on Colab by pulling from this URL. You can see here that image been saved here locally. And we're going to save the image into a variable called img. It's a Tupperware box with some rice, I guess red peppers, broccoli, and I don't know, mushrooms, or no, maybe chicken. Now we're going to set the model to be Gemini Pro Vision. And instead of feeding in text into the generate content method, we're putting in the image. And we're printing out the response.text. We actually didn't prompt it with anything other than the image. What's come back with, by default, a description of the image. Chicken teriyaki meal prep bowls with brown rice and vegetables. In this bit, it shows how you can do a multimodal input. There's a list here. So the first item in the list is a text prompt, and then the second item in the list is the image. What I want to ask it is, please list out all of the different foods in this food box and estimate the amount in grams. Please calculate the total number of calories in this meal. I think it's just wrapped onto the next line. Just put a slash there. In this case, they had to put response.resolve. And then we're going to print out the response.text. That is so cool. Look at that. The food box contains half a cup of cooked brown rice, broccoli, carrots, bell peppers, chicken, soy sauce, and sesame oil. I guess I must have taken that from some recipe. I don't know if that's half a cup of rice, but that looks roughly right. That's incredible. In the notebook so far, what we've done is just input some text or text and image and gotten a response as a single turn. In this next part, we're going to show how it works with chat conversations. And chat conversations really is just the same thing, except there are multiple turns. So you can keep talking to it and it will remember what you have said in the previous turns. The method that we will be calling on the model is different from before. Instead of calling generate content, which we would have to store the conversation history and feed it back every time, by calling the start chat method, it automatically does it for us. So we're going to create a new instance of the model. And in the previous section, we did model.generate content, but here we're calling the method start chat. Apparently the Gemini Pro Vision model is not optimized for multi-turn chat yet, so we can only use Gemini Pro. And on chat, we call the method send message. How much does it cost to use Gemini Pro? I think it's confused Gemini Pro with a crypto service. Let's see. Google DeepMind's Gemini Pro. And actually, it didn't really give us the answer. But let's look at the chat history. You can see both of the turns here. So the first question was, how much does it cost to use Gemini Pro? And then it came back with this thing about some crypto service. And then this was the second turn. And says you can keep sending message to continue the conversation, and it will remember the history of the conversation by itself. Okay. How about the cost of using Palm 2? Oh man, it's like it's things I'm asking about the Palm Pilot. Apparently, the Gemini models can also support embeddings. here on Gen AI, we're calling the embed content method. We specify the model as being the embedding model, and then we put in the content that we want to be embedded. Task type retrieval document. It will return the embedding for this content. You can see that the embedding format for Google is a list of 768 numbers as opposed to OpenAI's, I think it's 1,536. You can do batches, pass in a list of multiple pieces of content, and get back a list of embeddings corresponding to the number of pieces of content you fed in. Oh, interesting. You can use this method to pass in the whole chat history. Instead of the list of text that we passed in just now, in content, we can just pass in the chat history, and it will give us back 4 pieces corresponding to parts text. In the last part of this notebook, we're going to go through some advanced use cases. And the first advanced use case is about the safety settings. So I'm supposed to put in a questionable prompt here. How do I make a bomb? I was taking a bit of time to think about that. So it failed to fetch. And then if we look at the prompt feedback, it didn't really work. Anyway, safety features need further investigation. Apparently, what Google allows you to do is to block some of the safety guardrails. If you put block none for one of those safety settings, you should be able to put in the corresponding prompt and be able to get an answer. That's interesting. That allows you to do that. I'm not going to test it. All right, the next advanced use case, encoding messages. The SDK that we used in the first part of this notebook is the easy version. But this section shows the fully typed equivalent so we can understand the lower levels working and so have more control over it if we wanted to. We need to import the generative language client library as GLM. Let's have a look here. This part is the same as before. We create an instance of the model, and then we call generate content on the model. But if you remember, when we were using the SDK before, we simply put our text here. However, by using GLM content, what we're able to do is to have more granular control about what content we're actually passing it. For example, we can pass it text and an image, like so. We call resolve on the response, and then we print out response.text. I'm actually not really sure at this point what's the benefit of writing this out in the verbose way, but I guess maybe there'll be functionality later on where it'll be helpful to have access to this level of granularity. Multi-turn conversations. Apparently, the chat functionality that we used just now is just a wrapper around the generate content, just to save us a bit of work from storing the chat history and then having to pass it back into generate content. If we were doing it ourselves, we would create an instance of the model, and then we would have a list of messages that we will keep adding to every time we get a response and every time we ask a question. And then it will pass this list of messages into generate content to mimic multi-turn chat functionality. For multi-turn conversation, you need to send the whole conversation history with each request. In this case, we have a single turn, and now we need to append to the messages list the role model, so this is the model response, and parts being the response.text. And we want to append our next question. So the role is from the user, aka us, and parts would be, okay, how about a more detailed explanation? And then we would pass the list of messages back to generate content again to get the next response. Under the hood, this is what the chat functionality was doing for us. If we print out messages, you'll see that it's a list that includes our original question and the response of the model back to us. Sorry, it's a little bit long. And then the next question we asked, but it doesn't include this response because we have to manually append that to the messages list. Finally, the generation configuration. So generation config argument allows you to modify the generation parameters. Every prompt you send to the model includes parameter values that control how the model generates responses. So let's say if we put in 3, only one candidate can be specified. Why? Oh, maybe this is just a limitation of the functionality for now, because it's commented as being able to support only one candidate. So the API is out, but it definitely looks like it's still work in progress. The good news is the SDK looks super easy to use, even easier than OpenAI. We'll come back next week and have a dig around semantic retrieval. This looks pretty cool. So there's another semantic retriever quick start, and it talks about being able to retrieve 10,000 documents as opposed to 20 files with OpenAI's file retrieval functionality. And also I'm keen to look into this one as well, function calling. So I'll call it a day. Oh, just realized I forgot to talk about pricing. Let's do that quickly. These are the prices that have been released for Gemini Pro. Instead of pricing on a per token basis, they're doing it per characters. Input price is half of that of the output price. If we look at OpenAI's for comparison, we have pricing also different for input and output across a number of different models, including GPT-4 Turbo, which is significantly cheaper than GPT-4, and also GPT 3.5 Turbo. And given that they quote based on per 1,000 tokens, it's hard to compare. So I've just done a quick summary here. So on average, I think there are around 4 characters per token. If we convert that, multiply these numbers through so we can have the equivalent pricing on a per token basis, we're looking at 0.001 per 1,000 tokens for input, and for output is 0.002 per 1,000 tokens. If we compare to OpenAI's pricing, it is actually quite similar to their GPT 3.5 Turbo. However, based on the testing that people have done, they think Gemini Pro is better than GPT 3.5, but not quite at GPT 4. So maybe it's slightly better value. And if we look at the difference in pricing between GPT 3.5 and GPT 4 Turbo, it's about a 10x difference for input and 15x difference for output. So it's going to be really interesting to see what the pricing for Gemini Ultra is going to be when we get it at the beginning of next year. So that's it for today.